morning, everybody, and welcome to another episode of Bri Fry the Math Guy. Now, don't get that mistaken with Bill Nye the Science Guy, because we're very different. Bill Nye is fake. Watch Bri Fry. Don't watch Bill Nye anymore. We don't talk about Bill Nye in this lab. I'm sorry, I got carried away back there. But anyways, today's episode we are going to be covering chemistry. Wait, this isn't the chemistry episode? Somebody told me you told me we were doing the chemistry episode. Why am I wearing this if we're not doing the chemistry episode? Cut the camera!
Hey, I'm sorry.
Today's episode is actually going to be about calculus. Yeah, so who's ready to do some calculus today? We have some very special guests here today. We have an entire classroom here to join us. So who's all ready to learn some calculus?
I don't have a ride home.
Alright, so we are here with...
I'm Cole.
Cole, I'm Bri Fry, the math guy. How are you?
Good.
That's good. Tell me a little about yourself, Cole.
Well,
That's great. Alright, are you ready to learn about some calculus today?
no.
Yes, you are. So, today we're going to learn about calculus AB. Do you know what that is?
I want to.
Okay. Well, calculus AB is actually an advanced placement class at the high school. So what grade are you in?
Second.
Oh, second grade. That's fine. Then you know what? I say we jump right into it. How about that?
I don't care.
Time for a lab. Let's go! So now it's time for a Bri Fry lab. I'm Bri Fry from the Science Channel. Catch me on Saturdays and Tuesdays at whatever time they decide to put me on.
Bill Nye's better.
We don't say his name here. So, now that we got that out of the way, rule number one's taken care of. I'm cool, you're cool. How about a little bit of tour of my laboratory before we get started? Come on over here, let me show you what we got.
Help.
Alright, so, first things first, I want to get a couple things done. These are UV lights. Be very careful with them, they're going to make you glow. It's really cool. Don't touch them. Okay. This is my robot arm, okay? You can move your robot arm whenever you want. He's going to help us do some calculus today. We need protection at all times, so there's always helmets in case you need helmets. Yes, there you go. Nice and safe. It's safety glasses, all right? Now, we don't need those right now. We don't need them right now, okay? Now, this is the microscope. This is how we're going to look at our equations today, along with the telescope. Sometimes you have equations that take place in the sky. Now, this is very important. Listen closely. Okay? See these here?
Yeah, I see them.
these?
Colorful glasses.
These are beakers. This is for my chemistry episode, okay? So please don't mess with them, all right? But this one's okay. This is my drink. We are sponsored by Raspberry Lemonade. So, cheers to Raspberry Lemonade.
No, you're not.
That's not raspberry lemonade. Don't drink that. One of those is raspberry lemonade. That's not. Okay. Alright, so let's get into our lab now, shall we? First things first, just before you always want to be in uniform when you're ready to do your lab, okay? So for instance, I'm going to do this lab because I am in the proper attire. You see, if you're going to be a scientist, you need to be in your lab jacket, no pants. Lab jacket, no pants. You wear a lab jacket, don't have to wear pants. It's constricting and it will harm you during the lab.
What?
Alright, so we are now going to start today's lab. Now I have Cole to the side because he's not in the proper uniform in this.
No one likes you!
Cole, we're filming right now. I need you to be quiet, okay? Okay. He's not in the correct uniform, so now we're going to get this started. So, if we would please it is time for lab lights. Boom. Today's lab is going to be about antiderivatives. So now that we have our lab lights on and we're ready to go, I have one equation for us today, and I'm going to walk you through it, see how we can find the antiderivative, and figure out how we can relate this to the real world. And I have it underneath the microscope here. It's a very small equation that requires a lot of prestigious work. So come on closer, let me show you real quick here. Don't be shy, step right up. Now, we're going to take a nice, real close look at this equation, shall we?
Hi, Bri Fry the Math Guy. My name's Cooper and I have a problem. I have a bowl of soup and it keeps changing temperatures. Is there a way to figure out the temperature of the soup over time?
Well, of course, Cooper. We would love to help you out today. One simple lab will help you out. I'm going to show you using antiderivatives. Here we go. As you can see, we have antiderivatives.
Oh.
And here's our example. Now, this seems a little bit confusing at first, but it's quite simple, really.
Oh.
So, we have a function. F of x equals 4x to the third plus 3x squared minus 2x minus 1. I'm going to show you how to find the antiderivative of this equation. So, as you can see in this graph, this is a graph of this function. And I have some shaded areas here because we are basically going to find out the area of the shaded region, and that's where the antiderivative comes in. So, to find this shaded area, well, the shaded area, in case you're wondering, goes from negative 1, I should label that here, negative 1 all the way to 1.
Okay.
And so we're going to find the area of that, which means this is 2, this is negative 2, and then just in case you're wondering, this goes 1, 2, 3, 4, and then so forth down here, negative 1, negative 2, negative 3, negative 4. Mind Bri Fry's handwriting. I'm right here. Just to show you what that looks like before we start to get into the math, if you can see down here, I'm going to draw a little integral margin here, and we're going from negative 1 to 1, and that's what that little squiggly line is here. Alright, and then what you want to do is you want to put, you can put it probably, I mean you can put it in parentheses if you want, I will just for, but it's 4x to the third plus 3x squared minus 2x minus 1. Now, when you're doing antiderivatives, you want to make sure at the end you put dx, and by putting dx there, it's basically saying, hey, we're going to do an antiderivative. Negative 1 to 1. F of a, or I guess we don't have to write f of x. Silly me. Silly me. And then in parentheses, 4x to the third plus 3x squared minus 2x minus 1 dx. Alright? So now here's what we're going to do. Now there's it's as like the derivative, the antiderivative is the same thing, but it's just the opposite. So for the anti and antiderivative. So here's how it's going to start. So you're going to take this, and this is going to end up going out to the back, and then the dx you can take out of the equation as you're writing it. So 4x to the third, instead of taking away the third and going to x squared, we actually are going to add 1 on, and then put that in the denominator. So 4x third is going to become 4x to the fourth over 4. And obviously, we know that you can simplify that, but we'll simplify that further as we go. And then so plus, and then you do the same thing with each variable here. So 3x squared becomes 3x to the third over 3 minus 2x becomes 2x squared over 2. And then you might say, well, Bri Fry, what do you do if there's no x?
I don't know.
Well, it's quite simple, let me tell you. You just add an x in there. So minus 1 becomes minus 1x, or you could just say x, and since it's basically x to the 1 power, that's x over 1, and we'll write it just for fun. And don't think you're done there, because you also have to draw a line right here, okay, and that's just to show we're going from negative 1 to 1.
Okay.
If you know what the simplified version looks like, I'm going to get rid of the simplified version just to make some room on my chalkboard here. So now what we're going to do is we're going to plug in our greater number, which in this case would be 1. So we're going to plug that in for x, and then we're going to subtract the same equation plugged in with negative 1, our far left, and that should equal the area of our shaded region.
Okay.
So, by simply, with a big parenthesis, we will go 1 to the fourth plus 1 to the third minus 1 squared minus 1. And then we're going to subtract, in parentheses, negative 1 to the fourth plus negative 1 to the third minus negative 1 squared minus negative 1.
Yay.
Do the math and grind this out. This actually ends up equaling 0 minus 0, which means the area of your shaded region from the graph before is actually 0.
Oh.
Simply because, as you saw in the graph earlier, it went as a positive, came back to a negative, and then went back to a positive again. And it turns out those shaded regions in the positive and negative part of the graph ended up equaling each other out, meaning the area of that shaded region leads to 0. But there's a little taste on how antiderivatives work under the microscope.
Yeah.
Alright, so that was our anti-derivatives lab. I hope you guys enjoyed it. Let's go catch up with Cole and see what he thought about anti-derivatives. So, Cole, what did you think about Bri Fry's lab?
It was bad.
That's great to hear. He said it was really good. I think that's what I heard. I think that's just code word. That's funny. Did you learn something?
No.
Yeah, you did. Oh, yeah. Do you have anything else to say to our viewers?
My ride's here, so...
They can wait! Well, unfortunately, that's all the time we have today on Bri Fry the Math Guy. So tune in next time for next episode where we should be covering chemistry. But we'll just have to see. So now I'd like to give a special thank to our sponsors.
This film has been brought to you by Calculus for all your math needs, and by Prozac antidepressants for those long nights of AP Calculus.